Hello student, we come together for continuing our topic related to nano electronics. The paper code for this paper is PE-EC505A. I am Arnav Das. Today we discuss about the topic of module 1 and which is the basis of the quantum mechanics and also the Schrödinger equation density of state. When we are talking about the particular duality, that is the wave and particle duality, that time two things will be rise to us. First one is that particle like wave behavior, and second one is the wave like the particle behavior. This kind of thing is analysis after the examination of photoelectric effect for particle like wave behavior. And if we talk about the wave like the particle behavior, that time this kind of thing is arise when division germer experiment is happen on there. That means each and every cases their ultimate thing is come to you that the wave work as a particle form or the particle also can work as a wave form. If it is, then that one will be defined as a wave particle duality. In the mathematical point of view, the momentum of the photon is p equal to h pi of lambda, and the wavelength of the particle is lambda is equal to h pi of p, where lambda is called the de Broglie wavelength. Now it has come to you that the word is the uncertainty principle. This is also defined the Heisenberg uncertainty principle. After the 1927 it is discussed and also explained there. It is impossible to simultaneously describe with the absolute accuracy the position of the momentum of a particle. Also, it is impossible to simultaneously describe with absolutely accuracy the energy of the particle and the instant of the time the particle has this energy. The Heisenberg uncertainty principle apply to the electron, that is the charged particle, and the state that we cannot determine the exact position of an electron. Instead, we could determine the probability of finding electron at a particular position. So uncertainty principle is the so important one for identifying the location or the position if there are charged particle can be or not. So Heisenberg uncertainty principle is most or one of the important term for the quantum mechanics. For the quantum theory for semiconductor, the charged particle are the electron or the hole. So if you are interested to identify the behavior of an electron and the holes, that time the Heisenberg equation or Schrödinger equation is the important one, because mathematical description of motion of the electron in quantum mechanics can derive or described by the Schrödinger wave equation, with also the Schrödinger equation solution, which also define the energy band structure and the probability of finding an electron at a particular position. So Schrödinger equation is also an important term for the quantum theory for analyzing the free charge or the charged particle. Is it present or not for a particular position? For the Schrödinger wave equation, if you write down into the form of the one dimensional, that is you are predicting only the one dimensional. In this case, the expression is written for the dimension of x. That is, here the time domain form for this one dimensional Schrödinger wave equation written as a minus of h cut square pi of 2m del square by psi of xt, where psi of xt is defined the wave function, and plus of v of x wave function equal to g of h cut del of psi of xt of del t. If you identify which one each and every one term, that time the psi of xt is defined the wave function, and the psi x comma t square dx the probability to finding the particle within the range of x, and the x plus of del of x at the time of t, that is for the instant of time. If you are interested to identify in between the location x and the x plus of del x, is there charged particle can be or not. Psi of x comma t square, the probability density at the location x and the time t. V of x is the potential function and m is defined the particle mass. So, from this Schrödinger equation, the one-dimensional formation can be identified for detecting the location or detecting is the charged particle can be the particular position or not. Schrödinger equation can also is comparable with the classical variable with also the quantum variables. How? If we consider for the position, for both cases it is defined by the x. If we consider for the function of the position, that time also it is defined by the phi of x. This is the f of x. If we consider for the momentum for the classical variable, that time it is defined the p of x, and the momentum in this case for the quantum it will be minus of h cut by j and pi of del x. And for the energy it is defined the E, and the energy for the quantum variable or operator will be choose as minus of h cut j into of del pi of del t. So if we are talk about for the wave function for the three-dimensional point of view with respect to time, that time the wave function can be defined as a form of x, y, z. We are taking here the Cartesian coordinate form. Here the coordinates are defined as the x, y, z with also the t. The probability of finding the electron within volume. That means the wave function can now will be written down as that is the total one. What is the finding of probability? It will be, if we consider the total volume, it will be the one on there, and the expression will be on that case. That case it will be defined as a form of integration of minus infinity to infinity for each and every cases of x, y, z. That is the psi of conjugate. This is del of x, it will be equal to of 1. In general, the restrict psi of x one-dimensional analysis. This is for easy, but if you want to identify the total volume, that time the wave function for the three coordinate or three-dimensional you have to analysis. Schrödinger wave equation into the form of the classical mechanics, it can be defined the total energy is equal to the kinetic energy plus of the potential energy. For the kinetic energy, it is defined by the p square by of 2 of m, and the potential energy is defined by the v, and the summation of these two is equal to the E, that is the total energy. So if you write down the individual term into the form of the wave expression, that time the formation into the form of the one-dimensional, it will be look like this. And if you consider for the three-dimensional point of view, that time the expression was the below one, that is the h square by of 2m del square by p psi of x comma of y comma of z comma of t plus of v of x y z p psi of x y z t equal to g of h cut del of p psi x y z t and by of del t. Now, from this Schrödinger wave equation, you can find out for the free space what happened to the charged particle and what will be the expression also. You also able to identify infinite potential. Well, if it is that time the charged particle, if it is present, that time what kind of nature it can be occur on there, and you also be able to identify for the potential barrier, that is the infinite potential world is present, and in between there and charged particle or particle is present, that is the tunneling effect is occur on there. That time what kind of condition can be occur on there, and obviously here it will be work as non-volatile memory form. So this is an important term when you are interested to design the non-volatile memory into the form of the nano electronics. Separation of the variable, that is the psi of x, is the one-dimensional point of view from wave equation, where you just use as a psi of xt. If you just differ between as a position and also the time, that time psi of x is defined the spatial dependence, and phi of t is defined the time dependence. And if you write down the previous already explained the one-dimensional expression for the Schrödinger one, it can be written down as a form of that as a difference of this separation of this variable as a form of this one, that is here looked at. This is spatial dependence and the phi of x is separated. Now each and every one term, if you are divided by using the phi of x and the phi of t, that time the expression can be modified or can be written as a form of this one. And from this, if you just solute, that time here the right hand side can be only present the time domain function, and if you just talk for the left hand side, that time there only function f is present on there. The right hand side portion is defined the separation for constant, that is the eta is equal to j of h cut by of phi of t del of phi of t by of del t. This one is defined the separation constant, where from this you can be able to identify the total energy is the separation constant. Here this term, that is the left hand side term, is defined the total energy, and this one term is defined the separation constant. So total E, that is the energy E, equal to separation constant eta on there. So if you just use this separation constant, that is the eta is equal to j of h cut by of phi t del of phi t by of del t, that time from this you can also calculate what is the value for the phi of t, and this will become as a value of e to the power of minus j power of eta of h cut into of t. So if you just use the previous known expression, that is the energy E equal to h of nu, where the nu is the frequency on there, what kind of frequency is applied on there for moving the particle from one place to the another one. So from this you can be identify that the expression can be write down for the total energy is equal to h squared of omega, because the omega is equal to 2 pi of you already know, and this is also can be write down of 2 pi of nu, that is omega is equal to e by of h cut. So that one is applied in this position. Ultimately the expression is coming as a form of the e equal to h cut of omega. So from this you can conclude that total energy, that is the separation constant, can also write down as a form of the E of equal to eta. So phi of t, which is written as a form of e to the power of minus j e by of h cut t, can also write down e to the power of minus j of omega t. Schrödinger wave equation in the modified expression form can be written down. We just talking about the left hand side, already discussed the previous few slide above. That time the left hand side portion is the total energy, so total energy E is equal to this one. From this, if you just solute, that time the boundary type of condition can be made, that is here if you consider only, here only consider for the value for the del square of p psi of x by of del x is equal to 2m by of h square, this one would become on there, and ultimately you know that the total volume form, the wave function value will become as a value of 1. So ultimately the probability of finding the particle, their condition can become as a p psi of x should be the finite and the single valued and continuous, and second one condition will be there, the del of phi x by of p psi of x by of del x, it is also will be the finite and the single value and the continuous, because from this equation you can conclude that this one term equal to 0 with also this one term also equal to 0. Now if we are talking about the, if it is the free space, that time what happened, that is the potential is not applied, this v of x is equal to 0, that time this expression, that is the total energy E is equal to 0 on there, and the expression can be written down as a form of the v of x equal to 0, due to the reason of v of x is equal to 0, it can be, just a minute, it can be as a form of, this is v of x is 0 on there, so it can be write down del square p psi of x del x square plus of 2m by h squared square e of p psi of x equal to 0. So this is the loss particle derivative nomenclature will become on there. Now we are talking about the circuit analogy point of view. Let we are considering here and the parallel combination of the capacitor and the inductor. So here current will be distributed form, and that one will be the I is equal to IC plus of IL. That is the IC is defined the current through the capacitor, and IL is through the current for the inductor. So from this expression we can write down the I equal to C of dVt by of dt plus of 1 by L integration of Vt of dt. That one should be a constant term, because for a circuitry their I is the constant one will become in this condition. So from this, due to the reason of you are not applying any kind of voltage, so that time that is the V equal to 0, that time this one can be write to equal to 0. So from this you can be able to identify the what is the resonating frequency or the oscillating frequency on there. So this frequency will be, this is 1 by of root over of L and C. If you compare this with a coefficient for the free space wave equation, that time this can relate that this is p psi of x is equal to a into of e to the power of plus j 2 me by of h cut into of x plus of capital P of e minus of j root over of 2 me by of h cut into of x. So that one also into the time domain form can be write down as such. If you are considered for the traveling wave, that means the e to the power term is the positive. That time the ae of j of kx minus of omega t. From this, where k is defined the 2 pi of lambda and lambda is defined the h pi of p. So from this you can be write down the k is equal to 2me compared, if you compare with the equation already known by you, that is k is equal to 2me by of h cut, and from this the conclusion can be made that this is p is equal to h cut of k, that is lambda is equal to h pi by of p, and also it can be write down 2 by h cut by of p. This is due to the reason of the lambda value calculation point of view, and lambda is defined the d Broglie wavelength. So lambda is equal to 2 pi of k, as we told, also discuss in here, and also you can conclude that k equal to 2 pi by of lambda. This is an figure is given to you for the potential function of the infinite potential world. That means if the Vx is applicable for the infinite point of position of time, look that if it is and wall is present, that time it can be categorized into the three region, that is the region 1, 2, 3, and the separation between two regions is that when the x is equal to 0 and the x is equal to a on there. This figure is identify the potential function and the corresponding wave function solution for the case. This one, when the potential function is finite everywhere, that time the wave function will be look like this one. If you consider the potential function is infinite in some region, that time the formation will become as such. This is also conclusion point of view, another one figure, so it will be easy for understand for the previous lecture. That is the particle in an infinite potential wall. So that means there are two wall is present. This wall is wall, another one is present in this position. This cases this one and this one is present on here. So what happened? That cases option A is defined the four lowest discrete energy level is given to you, where the n is equal to 1, 2, 3, 4. What happened if individually level you are considering on there? For the option B figure, it is defined that corresponding wave function, if you consider for the state as n equal to 1, that time the wave function as a form of this one, and if you are considering n is equal to 2, that time the wave function will be look like this. For the 3, it will be as a form of this one. So if you just put the value for the individual state equation, that is the quadrature equation, that time this kind of waveform so easily can be gotten on there. Figure 3 is defined that is the figure C is defined the corresponding probability function. That means how much or how or is that the particle can be present or not. That the high probability that for the state of 1, this in between, there the highly chance that the particle can be. If you consider for the state 2, that time the probability of finding the charged particle in between these two sections, same way if you consider for the n is equal to 3, that time the highest probability come for getting the charged particle in this through region for the state of 3. So this is the way by which you can also really define, or you can suggest that, or also probability will be that finding and charged particle. So thank you for all of you for listening this kind of lecture, and the remaining two figure also discuss that this is the potential barrier function for the 3 region. This is also defined for the x is equal to 0, and the another one boundary wall is present at the x is equal to a. If in between there an wave function is propagate, that time the formation will be look like this one. So thank you very much for listening this one lecture, and we will discuss another one topic for the next day, and till have to say good day and bye.